Safety instrumented systems require periodic proof testing. Most facilities today find this testing is either highly manual and expensive or highly suspect since conventional online testing does not detect potential trips. Hi, my name is Dave Huffman with ABB. Today I'm going to demonstrate a partial stroke test on the 800XA system and how it's used to improve safety while maximizing uptime. We're going to start the demonstration by showing the DTM for the valve. In the gray area to the left side, we can see that one of the options is to schedule partial stroke testing. So we can have it set up to be able to do numbers of days of interval and times and things like that. So that's one of the features that the DTM itself provides. Below that are settings related to the partial stroke test, where we're able to set how much travel the valve will have, what the speed of the test will be in percent change per second, also how much dead time is going to be experienced at the end of the test or the very bottom of the test itself. And then one of the other critical key factors is the friction high limit, which is during this demonstration will actually trigger a fault that we'll see and be able to have further diagnostics performed on the valve. To the right-hand side are buttons that allow us to perform the test or load information and things like that from the previous tests and so on. So we're going to trigger the test with the Perform Diagnostics button. From this screen, we're going to then switch to an operations display where we see a faceplate that relates to the partial stroke test and also a chart at the bottom where we're showing the valve travel in percent. The upper valve closest to the reactor is the valve in question that we're using, ESV200. Now that the test is started, we'll notice that up near ESV200 on the graphic, there's an indicator that the test is being performed. This is a way that the operator can tell just simply on the graphic that a test is being done. And on the faceplate, we can notice that there are flashing symbols telling you that there's travel on the valve, the PST is running, and that the PST status is running. The valve has reached its bottom position and is now starting back up. Basically, the test has been completed at this point as it returns to normal. The valve has now reached very close to maximum position. The test is now completed. We see a date and time stamp for it. We see that everything's returned back to normal. We're now going to change screens, go back to the DTM, and we're going to wait for the test results. So now we have the partial stroke test summary results published. They pop up immediately showing what the conditions are. We can see in this case that the friction test has failed. So from this point, we now need to go check other aspects of things. So we're going to show the actual valve position graph of the test, where we can see that the pressure signature and the position of the valve, and this is recorded as part of the history for the test itself. From here, we can go back to the DTM itself and look at the results published into the DTM in terms of the information. Now from the DTM, we're able to go look at the alarm list and see that we've got an alarm that has told us that there are results available and that friction is above normal. So now we need to go out and look at the asset reporter as part of the asset management within 800XA, and we can see from this description that we have an alarm for the activity in the valve, and that we can then go out and look at the detailed conditions of that, and we see recommended maintenance action that could be taken on this valve. Within 800XA, from this type of information, we could then proceed to create a work order and so on if we're connected to a computer maintenance management system. In summary, a properly integrated partial stroke test implemented as part of your overall proof testing strategy will enable you to 1. Eliminate the cost of manual testing, 2. Improve safety of your facility due to the accelerating testing cycles, and 3. View information in context without having to interface with multiple or separate systems and access action-oriented reports while making it easier to catch problems with time to plan and act. To learn more, visit us at abb.com or give us a call to discuss.